let's also expand, let's say 38. And this is on page 501. And this is a little extreme, but we have to see an example like that. X to the fourth times the square root of x squared plus 3 divided by x plus 3 and everything. I think it's the fifth power. Yes. Let me put this away. Okay, so we are asked to expand, meaning use very, very simple logs. Apply all three properties till you can no longer apply any. So if that's the case, the starting point has to be, if you want to say anything, please always stop me. So you have to start with a quotient. So then this is natural log of the numerator, but minus natural log of the denominator. So this is ln, ln, ln. At this point, I realize that this is a product right here. And this one, the only thing I can do is just bring 5 in front. There is nothing else. But this is a product. And we know that the product rule says natural log of x to the fourth plus natural log of the square root of x squared plus 3 minus 5 natural log of x plus 3. This is completely done. No one can simplify that any further. But these two can be simplified. The same idea.
Can you shift the paper left a little bit?
To my left?
Yeah, and then down. Down. And then left.
This is very interesting. I thought you were seeing what I see, but apparently not.
No, it's all like canted to the right, and you need to like turn counterclockwise. If you want to, like, I can see it now, but if you want to put it straight, you need to counterclockwise.
I can't because of the other camera. That's why I have those marks. I'm so sorry. That's why I have those marks here, so then the camera can record. But of course, I want you to see. If you can't see, that it's not good.
I just couldn't see the x plus 3 at the bottom right. But I can now.
Okay. Stop me anytime, please. Because I thought I see what you see, but apparently not. Okay, so all we have now to do is just put the 4 in front. Can anyone remind us what power is the square root?
2.
Careful. The square root cannot be power 2. Let's try again.
Is that 3?
The square root cannot be power 3. So let me just say this. X squared and the square root of x cannot have the same power. If this one has power 2, this one cannot have power 2. So what is the power of this? X to what power?
0.
X to power 0 is 1, assuming that x is not 0.
X.
We need the power.
T.
So we want the square root of x to be replaced by something to a power, x to a power. It's power 1/2, we know that. Every radical represents a fractional power. If it's not a fraction, it's not a radical. If it's radical, it has to be a fraction. So x squared and x to 1/2 cannot be the same. Is that clear? We remember this, right? We've done this many times in the past. So what about the cube root? What is the cube root? It's x to which power?
1/3.
Very good. So please remember, every radical represents a power that is a fraction. if this is index 2, the power is 1/2. If I have, let's say, the 4th root of x to the 3rd, what will that be? What is the power for this one?
4/3.
It's always the
Or
index.
three-
See,
3/4.
the index. Yes, the index is always the denominator, so it has to be 3/4. Agreed? Please make a note of it. Is that okay, everyone? So it's 1/2 natural log of x squared plus 3 minus 5 natural log of x plus 3. Are we okay with expanding? There are no more rules that we can use here. There is nothing else. This is it. This is the final form. And as you saw, we started with a natural log of a complicated situation, and we got something like this. Much easier to work with. Do we need another condensing, or now we're going to have to go back? I should say backwards, meaning we're given this and we want to get that. So now we are going to condense. Do we need another example with expanding?
I think so, just so if I run across another scenario problem, I can have two go off.
Okay, so the promise is that we are going to redo those problems, all of them that we did on this, right?
Yes.
Okay, excellent. Would you like to choose? Please choose anything on page 501, and we're from 1 to 40, any problem you want. They're all expanding. Any preference, or I choose?
You can choose.
Okay, so let's look at 39. We have log. That's common log. The numerator is 10x squared, the cube root of 1 minus x, 7x plus 1 squared. Okay, where is the starting point? What do I have to do first? Or which rule I apply?
Difference rule.
Very good, because I have the quotient. So then I have common log of 10x squared, the cube root of 1 minus x, indeed, and minus log 7x plus 1 squared. Before we continue, I have a question. Assuming I don't have this just yet, how many factors we see in the denominator?
2.
Yes, I see 7, and I see x plus 1 squared. Excellent. How many factors we see in the numerator?
3.
I see 10, I see x squared, and I see the cube root of 1 minus x. 3 factors, agreed?
Mm-hmm.
So at the very end, I need to see 3 logs with positive in front and 2 logs with minus in front. I have 2 factors in the denominator, 2 factors will have negative in front, 1, 2, 3, 3 factors in the numerator, 3 factors will have positive in front. Okay. After we establish that, let's continue. So obviously I have log of this, plus log of this, plus log of that. So log 10. Let me know if you can see. Plus log the cube root of 1 minus x. And I have negative in front. You can put it in parentheses and use the product rule, but eventually you will have to distribute -1. So if you remember this little shortcut, you're not going to have to use parentheses. It's nothing, I don't have anything against parentheses. As you know, I'm in love with parentheses. But if you can simplify from the beginning, it's easier. Any questions on this step? Can anyone tell us what happens next? Can I determine this? Okay, let's try that first. log 10 is y. I have no idea what it is, but this is a log equation, and I can change it into an exponential. What is the base here? I don't see any base. What is the base? 10. 10 raised to what power is 10? 10 raised to what power is 10? Now I know what y has to be. Y can only be 1, indeed. So then this number simplifies to 1, and I continue from here. So this is 1 plus. How do I simplify this? Well, I have to bring 2 in front. That's the only property left that I haven't used yet. What power is the cube root? So I can put that power in front.
One-third.
Thank you very much. So common log of 1 minus x. Minus, no one can do anything to that. It's going to be an approximate number. I don't care for it. But now 2 again comes in front as a factor. Minus 2 log x plus 1. So this was another example of expanding. Now we're going to go backwards.
Can you, I just can't see whether that newspaper just real quick. Yeah.
So now we're looking at condensing, which is even more important than expanding. Why? Because this is what we need for the next section when we solve equations, exponential and log, especially log. Okay, so looking at problems 41 through 70, still on 501, and then we're going to apply the change of base formula, and also I'll show you again how to use the calculator for this. Would you like to choose, or I will?
You can choose.
Okay, so let's look at a numerical example first. Log base 3 of 405 minus log base 3 of 5. I need to go back to my recycle bin because I just put the lecture notes from last time in the recycle bin because I want to make a point. Where are my properties? I'll find them today. Maybe not. Yes, I did. So what I want you to understand about these 3 rules is this. When we apply log to a product, we get a sum. But also, we can go backwards. If we have a sum of 2 logs with the same base, that's a must. Then we can condense it into log base a of x plus x times y, because it's a sum. Same way here. We can go back. If we see a difference of logs in the same base, they have the same base, we can go back and condense it because it's a quotient. It's a difference. It must come from a quotient. Finally, every time we see a number that multiplies log, we know it's coming from the power of this expression. It doesn't have to be x. It can be anything. Whatever it is, so that is actually the power of that expression. So that's the point I was trying to make here. So then when we see something like this, we know that since they are in the same base, same base, 3, 3, and it's a difference, so this must be log base 3 of 405 over 5. Yes, I will simplify, and I get 81 405 divided by 5. And now I'm asking myself, can I find a number for this? Yes, in these sophisticated calculators, you just can plug it in. There is no need. It's much easier than that. So let's say log base 3 of 81 is an unknown number. But I know that every log equation can be changed into an exponential equation. How do I change this? Remember, we always start with the base. We raise it to this number. We go counterclockwise. 3 raised to y equals 81. But if you think for a moment, you will come up with a number that we raise 3 to get 81. Anyone? Can anyone give us an idea? What could y be?
4.
4. So that is 4. Okay, so let's say we don't remember this. One option would be to use these sophisticated calculators and plug in math, or press on math, and just scroll up and log base will pop up. So just click on A, and it allows us to put in the base, which is 3. Now go to the right to put in the number. It will be 81. Now when we press enter, we must get 4. There is no discussion there. Now if you don't have this calculator, it's okay. You can still use the change of base formula. There's nothing wrong. So if I don't know how to evaluate this algebraically using this, the most important relationship in this topic or concept in this chapter, then I can write the change of base formula. Let's say we want to use natural log. It's a ratio of 2 natural logs, not to be confused with natural log applied to a ratio. And we plug it in. Let's say we don't have this feature. I cleared it. So we have natural log 81, and we divide by natural log 3, and we close the parenthesis. And when I press enter, I have to get 4. So it's literally up to you. This is the easiest, and the more you practice this, the better off you are in this chapter. Okay, so that was a condensing situation, a numerical one. But let's look at something that is a little bit more cumbersome, if you want. Let's say 54. 5. If there is a 5 outside, 5 log base b of x plus 6 log base b of y. So 54 is the problem number. Okay, so let's see how we address this. I'm asked to condense into one single log. A log like this, with 1 in front and whatever else in here, I don't care, but 1 in front, and just one log. Okay, well, first of all, I have to deal with this before I look at this. So if I see a number that multiplies log, in this case 5, and in this case 6, where does that number come from, really?
Exponent?
Comes from the exponent. So this is the same with log base b of x to the 5th plus log base b of y to the 6th. Indeed. Now I can go backwards on this property. What does that say? It says that it comes from,
Multiply?
yes, exactly. So it comes from log applied to x to the 5th times y to the 6th. If you want to put in parentheses or not, it's okay, as long as they have the same base, and they do. That's why I copied the base.
Can you shift the paper again to the left?
I'm sorry?
Can you shift the paper to the left real quick? I just gotta write that down. Okay.
Do we need more condensing?
Yeah.
Very good. So let's look at problem 67. If at any point in time you would like to choose, please do so. 67 has 1/3, a bracket, 2 natural log of x plus 5 minus natural log x minus natural log of x squared minus 4, and close the bracket.